A little bit of information about me. I do the technical documentation at Datadog. I also do developer relations, which means I come and talk to engineers and developers like you. And it also means that I get to speak about monitoring. I'm also a prolific traveler, and I used to be a chef. But a little bit more about Datadog. So how many people are familiar with Datadog? Yeah? Awesome. So for those who aren't, Datadog is a monitoring service. So we do all of your infrastructure and application monitoring. We make it really simple for you to do that. To give you an idea of the scale of how much monitoring we do, we handle over 1 trillion points of data every day. So that comes to roughly about 15 million points of data per second. We also are hiring, so if you'd like to come and work in New York, you can check out that link. So I really love this quote from Henry Ford, the automobile maker, and he said that the only real mistake is the one from which we learn nothing, right? We already talked about failure. Armand mentioned that we should embrace failure because our whole point of our jobs is to build products, right? Build software, build infrastructure to support that, and we're trying to move as fast as we can. So failure is going to happen, and the way that we embrace that failure is that we should learn from it, how to make our systems better, how to make them more resilient. And one of the ways that we should do that is we need to collect data. So at Datadog, we like to say that collecting data is cheap, but not having it when you need it can be very expensive. So to give you just some baseline stats on how cheap it is to collect data, how many people use AWS? You store things in S3? Great. So you know how cheap it is. You've already stored data there, but for those who don't, roughly, if you store 10 gigabytes of data, it costs you about just under $4,000 every year. So that's not that much. On the flip side, when you have a failure, that can be very expensive. So Amazon, S3, they had an outage. The estimated loss for the S3 outage was $1.5 million US dollars for that outage, which was half a day, right? So that comes into the cost of how much they had to refund money to customers, how much money and time they spent on fixing the issue. So obviously $4,000 for a year of some data storage versus maybe hundreds of thousands of dollars or even millions of dollars for your company, that's a big difference. It's much cheaper to collect that data that you need. So we understand that we need to collect this data. How should we think about the metrics when we're monitoring? We like to say that there's 4 really good qualities of metrics, four things that you should value in the metrics that you're gathering. And the first is that they need to be well understood, right? If I understand a metric, but you don't, then that metric is not valuable to you. So everybody needs to understand what the metric means. A good example of this is in the 90s, NASA, the United States Space Agency, decided to send a probe to Mars. So it was called the Mars Orbiter. The idea was they would launch this rocket, and it would circle around Mars and collect information. They ended up working with another company, Lockheed Martin, to build this project. NASA traditionally uses metric numbers. They use grams, kilograms, kilometers, measurements like that. Lockheed Martin uses imperial, so they use miles and pounds, inches. Everybody thought they were on the same page. They just saw these numbers. Somebody assumed it was kilometers. The other person assumed it was miles. Guess where the Mars orbiter is now? It crashed into Mars. Yes, it does not exist anymore. So your metrics have to be well understood. The second quality that we need to have in our metrics is that they need to be sufficiently granular. So do we all remember the Olympics? They happened last year in Brazil. I really like the men's 50-meter freestyle swimming. It's a really, really fast event. So these are some of the times. I don't know if you can read it in the back, but nearly everybody completed the swim lap in 21 seconds. And we have to understand that for the granularity, if we measure on just whole seconds, everybody wins, right? They all got 21 seconds except for the last guy, so everyone gets a gold medal. But we understand that we need this granularity, so we measure on the 100th of a second, right? So we can see that now there is one person that gets gold and one person that gets silver. And it's the same thing with the metrics that you gather. You need to understand that for the systems that you're running, you may want 1 minute granularity. That could be enough. but oftentimes you want seconds, or sometimes you want sub-seconds. If you're measuring your code, you're often looking at things in milliseconds. The third quality of metrics that you really need is that they need to be tagged and filterable, right? We talked about moving to the cloud earlier and deploying to things like AWS. The whole point of the cloud is that it allows us to scale and allows us to distribute our applications geographically. But that creates a lot of data, and so we need to be able to tag to understand where the information's coming from, what systems is it coming from, what parts of the world is it coming from, so that we can start to filter our information so that we can see what's actually going on. And then fourth for your metrics is they need to be long-lived. You need to keep this metric information around so that you can see trends. You can see if there are patterns every week or every month, every quarter, right? Because we know that there are certain patterns. For example, if you have an online store, you might see spikes in sales before Christmas as people start to buy gifts for family. So being able to see these patterns and trends becomes very, very useful as we build our systems. So with these four qualities, now we need to know how do we use this data, right? So we like to break down data or metrics into three sort of groups or buckets. And the first we call work metrics. Work metrics are the high-level metrics that are important to your company. They're the things that you care about. So I like to use an example of donuts. I really like donuts. Imagine a donut factory, right? We're making donuts. We're sending donuts down the line. Your work metrics are things like how many donuts am I producing every day, right? I want to measure that because that's important to the company. Similarly, if you're running an application or if you're running some infrastructure, you want to know things like what's the throughput, how many successful web hits are you having versus how many errors. You want to know that overall performance. So you need to think about your work metrics first. The second type of metrics that we like to consider is what's called resource metrics. So again, if I have a donut factory, I want to know how much flour I have, how much sugar do I have, do I have enough to make more donuts? And similarly, with your infrastructure or your applications, this is how much CPU do you have, how much disk space do you have. You want to know if you're going to run out of disk space, right? The problem is that a lot of people focus on this too much. We always like to have these graphs of how much CPU am I using, but that doesn't mean anything without that first work metric. So you always want to focus on the value to your company first. And then our third grouping is we like to think of events. Events aren't actually metrics, but events give us some sense of context around what the metrics are doing. So if we see a spike or a sudden dip in our metrics, we want to know, is that a code change? Is that a scaling event? Why did our metrics change? So using these types of metrics or thinking of them in these groups allows us to get to the root causes of problems or the technical causes. So we can start with the work metric, right? The work metric is my website is down. Well, great, your website's down, so now let's take a look at the resources. Are my resources good? Is my web server functional? Is it? Okay. Is my database functional? Well, maybe my database is down. So now I look at the corresponding events. Did we have a scaling event? Did someone push a new configuration change that caused the database to go down? Then we can start to look at that resource, and that resource, that database, becomes a work metric for us, right? Or work metric for whoever owns the database. Maybe it's a DBA or another infrastructure team. So that's their work metric. And then they can look at the resources involved with that. For the database, does it have enough memory? Does it have enough disk space? Is it connected to the network? And they can check the events for that. So you keep digging down using this pattern until you find those issues. But this talk isn't just about the technical issues, right? We're talking about postmortems, and we know that technical issues often have non-technical causes. We're all people. So we want to collect the information around people as well, because the information of what you do is just as important as the technical information of why systems fail or why systems have outages. So the first thing in collecting the people data is to ask the question, well, who, right? We want to know who's involved. And I like to think of this as a police investigation, really, or a crime scene investigation. Oftentimes we say, who should be involved? Well, everyone should. but then we only talk to certain people. Well, if you think of it as a crime scene, if you're an investigator, who do you talk to? Well, you talk to the police or the paramedics, the people who responded to the incident, right? So those are very obvious. But the thing that people often miss is they miss talking to the identifiers or the people who witnessed it, right? So if you're an investigator, you talk to the police, but then you talk to the witnesses of the crime. Ask what they saw, how did they notice things, gather their information. And then the other thing that we often miss is the affected users or the victims, right? If you were to investigate a crime, you want to talk to the victim. How did they get into that situation? What did their attacker look like? Things like that. And similarly, as we think of outages, we often want to actually talk to not just the people in our organization, but maybe our customers as well. How did our customers notice the outage? Because they have a completely different perspective than we do. So speaking of the perspectives, when we talk about data collection for humans, we want to know what happened, right? So we want to gather the perspectives of the people involved. We don't want to know what they did, but more than just what they did, we want to know what they thought or why they made the actions that they did, what were their motivations. Because this is often very useful in resolving the problems. Because we don't want to just prevent people from doing things, we want to provide them the information so that they make better choices next time. One way to do this is to actually have people write things down. This is a quote from Richard Gwindon, but essentially, when you have to write something down versus just thinking it or just telling it to someone, it actually forces you to arrange your thoughts and to think logically through a problem. And then we've all heard this, right? A picture's worth 1,000 words. So more than just writing things down, capture images. Capture those charts and those graphs from your dashboards, because it's one thing for me to say that I saw a spike in CPU. It's another thing if I can show you the graph and you can see how it spiked, how fast it was. So we talked about who and what. So let's talk about when. As we're gathering information, we want to gather it as quickly as possible after an event. So there's been studies shown that human memory decreases sharply within the first 20 minutes of an event. So we want to talk to people as quickly as we can. There's also been more studies shown that you're susceptible to false memories. False memories being that you remember things that didn't actually happen. One good way to actually solve this problem and collect information quickly is to get your project managers involved, right? Most of us here are engineers or software developers, and we want to build things, right? As Armand said, our whole goal is to build faster. So oftentimes, when we have a failure and we solve it, our next thought is what? Move on, right? Get back to work, build the new thing. But if you get project managers involved to block out some space, it allows you some time to actually go back and start to review and run your postmortem. Now, as we gather information from people, just like with technical data, we're prone to having data skew or data corruption. But with people, it's a little different. So we have things like stress that's involved. And you need to be aware of this and accommodate for it as you have incidents. Because as much as it's good to collect that information immediately after an event, sometimes you understand that people are under stress. Or if the incident happened at night, they may be sleep deprived or they may be facing burnout. So provide them enough space so that they can recover, and then do your postmortem. A few other things that cause corruption in the human data that we're collecting. One is blame, right? My wife and I often talk, and she speaks Spanish, so often it's no me culpa, right? You hopefully work in an environment where people aren't pointing blame, right? Because if it's no me culpa, then I'm not going to tell you what happened, right? Because it's not my fault. I don't want to admit to that. If we work in environments where we're not blaming others, where we're assuming that people are trying to do the best job that they can, well, then they will actually tell us the truth, and we can actually understand what they did and why they did what they did. A few other different types of data skew or corruption with people is bias. So bias is like anchoring, placing too much weight on one particular fact and ignoring the rest of the facts around the incident. Or things like hindsight bias. Hindsight bias being the assumption that someone had information and asking them, well, why didn't you do this? Or why didn't you do that? Well, they would have done this or that, what you recommend, if they had that information, but they didn't have that information. So we need to avoid that. Outcome bias is another big one. Outcome bias says that the results of my action are indicative of my actions themselves. So good actions lead to good outcomes, and bad actions lead to bad outcomes, which isn't always the case, right? I was recently introduced to guaro. I think it's delicious. I could go out and drink a bunch of guaro and then go driving around and not get into an accident. But that doesn't make that decision a good decision, right? So don't drink guaro and drive, despite whether you get into an accident or not. And the last one that's really common is bandwagon effect, or following the herd, right? If you see something, say something about it. Even though nobody else may see that, or nobody else may have that opinion, you'll always want to share that opinion, right? So I'm going to jump into how we do postmortems at Datadog. As mentioned, we handle a lot of data, so we always are faced with incidents, things that we don't expect. This is how we examine those incidents. And a few notes as we do this: when we run postmortems, we email them to the entire company. So everyone in the company receives a copy of the report so that they can look at it. It's very helpful. Oftentimes we think, well, just the engineers care about it. Well, for us, that's not really true, right? Our salespeople care because they need to talk to our customers who want to understand why something was slow or why there was an outage. We talk to a whole lot of people in the company, and they all need to know various aspects of what happened. The other thing that we do is we schedule a monthly meeting where we talk about everything that's happened in the month. Because oftentimes when one team runs a postmortem, well, someone else on another team may have better insight or a different perspective, a different way that they might be able to solve something or solve a problem. So our postmortem has 5 main sections. The first section is the summary, what happened. And this is where we describe, just at a high level, what happened, but we try to keep 4 main points. The first is, what was the impact on the customer? We always want to keep that business in mind, the business value. So how did our customers see this, or how were they affected? The second is, what was the severity? So we want to capture information not just from critical or severe outages, but we want to capture information from medium and minor incidents as well, because we're trying to improve everything. The third is we ask what components were affected. So what parts of our systems were included in this outage or this incident? And then finally, ultimately, what resolved it? So we want to give just a summary of how we fixed the problem. So this is an example from one of our incidents that happened last year. This was just the brief summary. The summary was that we saw a bunch of increased latency. And as mentioned, you want to include those images. So as we can see in the description, it says there was an increased latency and increased 500 errors. But looking at the graph, we can completely see what that looks like, right? We can see all of those spikes. And then we ask those 4 questions. What was the impact on customers? Well, customers were shown a down page. We asked what was the severity. Well, that was major for us because customers couldn't actually access the service. The components that were affected, and then ultimately what resolved it is that we increased our AWS node to a large instance. So part 2 of our postmortems, we ask how it was detected, right? The whole point of running a postmortem is to improve our ability to detect outages and respond to things. So the 3 questions that we ask is we want to ask, did we have a metric? Were we monitoring the systems that we needed, right? Because if you're not having metrics around it, then you need to solve that. But more than that, nobody wants to stare at dashboards all day. You want an automated alert. So we ask, was there a monitor? Did we have automated alerting to notify us when something went wrong? And then third, we ask, how long did it take for us to declare an outage or to actually declare an incident, right? Because we want to decrease the time that it takes for us to do that. We want to get faster at being able to detect these outages. So again, jumping into our postmortem here, did we have a metric? In this case, we had a lot of metrics. And we also had a monitor, an automated monitor. And for this particular one, it took us about 3 minutes to declare an outage. So relatively fast. And again, include those images. Always include those images from your dashboards so that people can see what was happening. Part 3. So in our template of 5 parts, this is the third part, and we ask, how did we respond? And this is where we gather the information about who was part of the incident, who responded. So we note the names of who was responded. But a big thing that we do is we include Slack archives, right? It's very common for people in an incident to all get together in a war room or get together in a conference room and all work together and talk things out. But one thing that's really handy is to not talk, is to actually get onto Slack or whatever chat you're using, because that's an instant log. It's very, very hard when you're talking to people to come back later for a postmortem and remember what you were talking about. But it's very easy to go to Slack and pull up the Slack archive and copy and paste that. The other things that we ask for this is we ask what went well. So we want to identify the good practices that we have and continue to do those and promote those. And then we ask what didn't go so well. So we want to identify things that maybe didn't go well so that we can introduce new practices to improve them. So jumping into our postmortem here, we can see who the incident owner was, so the primary responder, the other people who responded. We have a link to Slack, as well as to our dashboards, so linking back to your dashboards of whatever monitoring service you have. And then we have the timeline of events as well. And I can't stress this enough. As much as it's really easy for you to go and talk to people, using something like Slack is very, very useful for gathering that information that you need. One other thing, as you're using tools like Slack, is that you can start to note things. As you're responding to an incident, you shouldn't try to do the postmortem during an incident. Your number one job is to fix whatever's broken. But as you're doing it, you may notice things, things that you want to solve later. So for example, if you didn't get notified, you want to make a note of that. And then later when we are doing the postmortem, you can simply search for the hashtag, pull up all of those notes, and include them in your postmortem. The fourth section of our postmortems is the deep dive. Why did it happen? So the technical causes of what happened, how you resolved it. For this one, it's pretty long, but it's really interesting. So if you're interested in how VPCs work, or virtual machines, take a look at this. There was some really interesting underlying problems with how virtual machines do networking. And then finally, the fifth part of our postmortem is how we prevent it in the future, right? The whole idea is to get better. So number one for this, as you come up with tasks to improve your systems, link those to your GitHub issues or your Jira tickets, whatever system you use to track tasks, because you want to ensure that those tasks get done. But for us, we have 3 main sections for these tasks. The now, things that we have to do right now, otherwise we'll have a problem. So these are your high priority tasks. But then we have next. Next are the things that we want to do in the next sprint, or maybe 2 sprints from now. They're planned work that we need to accomplish. And then finally we have later. A lot of times this gets missed when people do postmortems. Oftentimes when you have a major incident, that incident will be caused by things like having a really bad architecture or something fundamentally wrong with an application. And these require a lot of time to change, right? Nobody's going to change their entire infrastructure in the next sprint cycle. But you want to plan for these, and you want to capture these very long tasks. So we have the later section for that. And those often go to our product owners and our product managers, because they affect the roadmap of how we build our products. So again, example from our postmortem, we have a checklist here to ensure that things get done. We also link to the GitHub issue. And then we also have some notes, right? You want to gather those next step notes. As people accomplish these tasks, they'll start to see other issues, or they'll start to notice other details, and it'll bring up more tasks. So you want to include notes. And in this case, the note was that we shouldn't do this task. After one of our engineers looked into the problem, she noticed that this task really didn't apply, so we should actually skip it and really think about what was going on. So just to recap, as you start to do postmortems, as you start to analyze incidents, 5 major sections that you should have. The summary, right? The summary because you're letting everybody else know in your organization. So they want to be able to read just a quick summary. But then the other sections, how did you detect it? You want to ensure that you have monitoring on your systems, that you have automated alerts so that you can quickly detect and respond to things. Third part, how did you respond? You want to capture that information about who was involved, getting those Slack or those chat logs so that you can know what happened. Fourth part, you want to get that deep technical dive so that other engineers in the future can read about this and understand how the system worked, how it failed, how to avoid those in the future. And then finally, the most important, having those actionable steps, ensuring that you're taking steps and tracking steps to make progress. So I have a few more resources. I'll post the slides later so it'll be easy to get to them. But I have our postmortem template online, so you can simply copy that. Makes it really easy to use. A few other links. John Allspaw has a great article about the infinite hows, and it's his notion of how you find the issues and the causes behind the problems that we face. Also, J. Paul Reed has one about how blameless postmortems don't work. So being aware of how we blame and how we can be aware enough to respond without actually casting blame. And then a few more about blameless. So John Allspaw, again, has a great post about blameless postmortems. And as well as a gentleman named Dave Zwieback, he wrote a book about how we do postmortems while understanding that we're all humans. So that's it for me. That's a link to the slides.